Now it's a pleasure for me to introduce some topics. I changed a bit during the discussion that we have during the first day, given that it was interested in have some problem the use of telematics, and then I changed a little bit the directions, and I was more devoted to the use of telematics for improving. Telematics can be used for improving the urban freight transport under the point of view of operators and of cities. I'm sorry, this is okay. Probably you have some chat. It's not shared? Okay, you can see. Share it. It's shared now. Is a pause this?
That's why maybe.
And now why it's paused? Share. Your screen sharing is paused. Now, hey, well, how we can do?
No,
Antonio,
no.
we don't see the presentation yet. Haven't seen the presentation.
I don't know why it is pause. Stop sharing and try again. Is sharing now?
Yes, now let's see.
Now? Okay, I think then...
Antonio, sorry, Antonio, just present view. Not, yeah, just switch one.
Now?
Yes.
Now. Great.
Okay, perfect. I will to put this, I don't know where. Okay, now I'm sorry for this technical issue, and then I hope that we can solve it. I would like to introduce the reason of the scope of this presentation, then the relevance and how emerging technologies can help us with the city sustainability, the operations. Then we have a focus of smart city and city logistics, and then some issue that is some open questions. But then we have two examples that we can use and some conclusions. In particular, this presentation, I skipped some part of this presentation and it is more completed. And it's my pleasure to leave you this presentation in order that you are able to go inside and to check it for if you have some idea, some option to include this topic within your revision program. Then we know that as also Stanislav yesterday, we need urban transport within the city because we have to satisfy the request of the people. We need goods, we need food, we need clothes, we need anything. It's not possible to allow that you see that the freight is banned by the city. But it causes a lot of problems going from pollutant emissions. We have a lot of vehicles that sometimes don't meet the high level environmental standards. They are old in many parts of our cities. There is difficult by the administration to ban, to force them to have new and renovate fleet because the costs are very high to renovate, and the revenue by this type of operator is quite low. You have to think that transport is the share of the price. The share of the price related to the transport is less than 2%. It means that we buy something for 10 euros. The cost of transport is less than 2 euros. And this it means it consists of operator, the vehicle, and so insurance, and so on. And then if they have to come back again because we not are at home, we have to pay. Also, we don't pay more. And that is the reason that it's a very strong question, a very strong problem. We have some problem with the congestion, with the road accident, and so on. According to this, that urban area is quite changing. We have the increase of the online sharing because the people are more familiar with the new technologies, and then they are looking for the low prices, and but we have to buy, but we have to deliver. They want to deliver anywhere, anytime. They want anywhere. We have a lot of problem deliveries, failed deliveries. This problem increase the impact of franchise. And we, as planners and administration, have to limit, to reduce. Because on the other side, we have the consumers. People want a very nice city with the low vehicles, the high level of the availability, but they want also that I receive my product where I want and when I want. This is in contrast. Then our main effort should be to integrate that and to solve, to able to identify the best trade-off between increase the sustainability of the area and satisfy the need of the users. In this line here, we can see the level, the trend of the user to buy online. As you can see, in Europe, this is quite increasing, and in the last years, we have been also pushed by the problem of the COVID. The people became more familiar with the technology, and then we need to buy online. Then we have issue related to that the parcel delivery to end consumer is rising, as well as to shop and store, because we have, on the other side, I said, and before, we have a lot of parcel deliveries. And the other side, we have that the price of the land, the rent of the shops is increasing, the surface. And then the retailers tend to have all small shops where they don't have the store. And it means that we need just-in-time operations, just-in-time strategy. And they need them to have to buy, to sell some things that they don't have in the shops, but they want, not in the morning, but 2 hours later. This is increasing the number of vehicles. The vehicles could be low, they are smaller, and this is a problem for the city. Otherwise, we have we have an increase of the cost in terms of operation, in terms of sustainability. This is a very challenging question. Then we can also, as I said, we are in the sea of sustainable development. And mainly, we also in this project, we are concentrated in order to ensure a more livable cities. The sustainable goals are number 11. Then in this background, we can also to look to the telematics. Telematics can help us not only to stress the issue, for example, improving and facilitating the use of e-commerce, but also because they allow us to improve, to optimize the transport that we have within the city. In this, then the telematics is an opportunity, and it opens a new direction, and we have to be ready to create new planners, new engineers that are ready to capture these new opportunities. Then we have to, of course, why this last? Because also we can suppose that we ban, we return that we don't want to e-commerce, we return back, but is not. But we want to go ahead, and with sustainability means that we have to block everything, but already the time back with the evolution. But this is some philosophy that said, okay, we come back when we don't have the internet because it's better to stay and to go to the shop. We have more social events and so on. But our idea is not to come back with the evolutions, but is to go ahead. And for this, we want to have a smart development. And in this smart development, we want to create some way, exploit the opportunity offered by telematics, because we want to have an integration between the city, within the different stakeholders, the different suppliers, in order to create a more reliable system. Then we have which are the main the emerging technologies that we wanted to point out. Generally, we refer, also referring to the main question that the European handbook produced by 2 years ago by the European Commission. We refer to Internet of Things, the big data, blockchain, and artificial intelligence. Also, digital twins is one of the scope that we can use. Mainly in this presentation, we refer mainly to Internet of Things and big data, because it's the current, is not the future. For example, the other blockchain and artificial intelligence is starting. It's not, but it's not because it is not mature. But we are referring to a specific aspect of transport. We are referring to city logistics. Then this is the main technologies that is open the opportunity for city logistics that is at the beginning. Don't mean that we are at the beginning of the evolution of these technologies. In particular, we refer to Internet of Things and big data. And now we can see why we are referring to that. Because, for example, I anticipate some things of my speech, because we refer to Internet of Things, because it allows us to monitor the system, the transport system, and to have a constant update what is the system evolution, the step by step, in the time by time, day by day. Big data allow us to have a memory and of what we had in the past, because we can learn from the past evolution, we can update with the Internet of Things, and we create a new forecasting that is more accurate. And then also we have also blockchain and so on. Which are the benefits for the different actors? Mainly we refer, for example, transport enterprise. They want to optimize the delivery time. And the big data, Internet of Things, allow them to actualize the real-time information coming from the transport system and to create a more responsive service. In this way, they can, if they are ready with the methodology, the procedure for taking into account these two aspects, they can reduce their costs, operation costs, and then can meet more better the aspect or the request from the users. And in terms of public administration, in our point of view, is quite a supervisor of the system. They tried to merge different interests, and then they can use the public space in order to optimize, to meet the requests from the different users. Then, for example, they can provide information on parking, availability for the parking deliveries, or suggestion for find the best path to go from one point to the other. This is the possible benefit for city users in terms of economic, social, and environmental. We have, for example, reduction of traffic congestion, reduction of the operation costs. We can have also reduction of crash damages because they allow to reduce the interference between the users and so on. I think that this is quite clear, the benefit that we can have in the general sphere of the three aspects of sustainability. Then what we have in the city logistics. City logistics, we saw that we are in the smart development and smart growth. And as defined by the documents from the European Commission, this is the smart city is given by the intersection between urban energy production and use, urban transport mobility, and the urban information and communication technology. The intersection of these three, the main four thematic form, allow us to identify the smart city, because we are trying to move towards the smart cities. Then we have to satisfy the user need, creating connection between with the opportunities offered. Of course, the transport operator should have technological solution to improve sustainability and efficiency, because of course we have a lot of telematics uses by but here we refer to on the telematics that allow to have a strong impact on the impacts produced by urban by freight transport. Because, for example, we are not referring now here on some aspect, like example, the security that we have on our vehicle in order to reduce the consequences for users and so on, like for safety. But we are referred mainly to the reduction of the impact that we can use, for example, as a proxy, the vehicle kilometer channel. We have to that increase safety, reducing environmental impacts and conditions. Then we can have some tools that can provide proactive and tailored path advice in order to have a smart routing. In this way, they have our new planners should be ready to use this combination in order to create a more sustainable delivery planners. Then, of course, this route can be integrated in a more advanced tools that allow to plan to design each day by day the vehicle, the strategy for delivery. And then we can have a smart tools for routing and scheduling. Of course, this smart routing should be proactive. It means that they have to produce not a solution that is updated instant by instant. It means that I don't have to ask, for example, someone can say, but we go on Google Maps, we ask now which is the best path to go from here to the city center. But this is currently used. But the picture that we have now in this moment is not sure that when we go in the middle of the path, we can find the same situation. The challenge is that we have to provide the paths that take into account the evolution of the system and give us the real situation that we can expect when we are along the path, not a path that is built when we are now with the picture what is the situation. For example, we can have now the one link is blocked for congestion because of a bad parking of a truck. I go on Google Maps and they say that we have to use this path. It's completely different. When I am moving, this path can change because this is a temporary. Then our system to forecast that this is the situation is abnormal, is not a normal situation, that they need to merge the past information because the system knows that this link is always free. And then it is an unexpected situation that can be solved very slow. And then it is to merge the past information with the current and provide us the real information that we need. This is what we need. Generally, we have a few events that can be allowed to merge this learning process in combined past information and current information. For example, and then it can be used included in the current problem, routing and scheduling problem, in order to optimize and to provide a new solution. This is an example that after we can see in a few minutes. The learning process, of course, as I said, we have to merge the past and the current situation. This comes, and this past situation is possible thanks to big data, because we store the system. What is the evolution of the system in the past? For example, travel time each link. We know this, and we can store for a long time in the past. And we have the current situation that is given by the Internet of Things. Of course, the past information should be not today is not the same as yesterday or 3 months ago. We have to weight this information according to the distance from in the instant of the time when I am. And then we use, for example, learning projects that can be an exponential recurrent system. Referring to the path, our scope is to identify the best path from one point to the other. Why this? Because we have to optimize the time that for operations, operator on the point of view. If we reduce the time, the operation times, users are satisfied because they reduce the cost. And the other side, if we reduce the number of vehicles circulating, because we use less time, we have less vehicles during our city, we have a benefit for the city. In this way, in general, we have that the path cost is expressed by some attribute. We refer to generalized cost. It's a combination of the travel time, travel cost, monetary cost, and other components that allow to driver to choose a path than the other. Usually, this travel time, travel cost impact is a function of what is the situation of today, but not all today, but at which time. And it depends, and we can have this forecasting taking into account what happens yesterday and what happened today. For example, when we travel with the bus, we use it to go to work. If we have new services, we have some time to learn the system, and this is what we have to imagine. Then we have this cost is changing right? Each day by day and instant by instant. In general, then the cost can be of a path can be expressed as a function that is dependent on the attributes that characterize the time when I am. For example, today, now at 11, and or sorry, at 10:30, and what happens yesterday, the day before, today before, today before. Of course, the weight in this function of the information that I know of the past have a different weight in my perception. I remember what happened today, that I was blocked in a link in a road, but go ahead the time, this information weight less in my choice on the path. And this past is represent what happened in what the users experimented, and we know this information because it is stored in big data in our big data. The current situation is monitored and revealed by the Internet of Things. Now we know exactly which is the situation now. What happens when we use, for example, Google Maps, because they have a lot of information from the user that they use the mobile with Android, and they reveal where I am and which is the travel time on each. Then we have to combine this because we have to investigate the time. For example, for simplicity, use one of these attributes, the time, which is the evolution day by day of this travel time between one origin and one destination. And we have the past experience of yesterday and what I forecast yesterday for doing the same paths. Then the end is done in the, of course, we can see if we apply this the day before, this weight of the past information reduce also the weight with the definition. Then it's possible to combine this information and to build the cost due to the forecast, take into account of only what I experienced the day before. Now we have to go to use the current situation. Then what we have before, I can combine what the sensor that I have in the network provide me. And then we have the travel time that I can forecast for the current situation, looking at which will be the system. In this way, I can provide the right situation, not the picture of the network now, but taking into account what happens in the future. We did some example. For example, in Rome, we decided to have a depot in a suburban area and to have the delivering in 10 different customers. And we have, for each customers, we have a different travel service time in order to take into account, to avoid to have the combining effect between travel cost, travel time, and so on. We concentrate on travel time. And we decided that we have this, usually what they do, our planners in the city, in our enterprise, what do? They know which is the travel to the north from past experience, they know the situation, or can use Google Maps, which is the daily congested at time 9:30, and it can launch a problem or routing problem. And then provide, for example, this is the average, they can provide this sequence of visits. This is the right sequence based on the past information, the typical day, at the day. Then they suggest, okay, start, go to serve customer 4, then 7, and so on. But if I am today at 9:30, if they launch and they use the information on Google Maps to now in the current situation, the situation can be changed. And we have that it's not best to go to today to serve the customer 4. Of course, we don't have the service time window constraints. It's better that you go to serve customer 2 and then 1, 6, and 2. Then we can see that the sequence is completely changed. Then if when after that the delivery man serve the customer 2 and is finished at 10:15, he can launch again using Google Maps, for example, the picture of the situation. And we have another a quite similar sequence, but for the future is different. And he can do every time he's ready, he can launch. Of course, it's very complicated, it's for the users. But we can use the theory that we have applied before in order to merge, because what can happen here? For example, some link can be blocked for an occasion, for a bad park and so on. And the system going not to 6 and so on, but moving another way. We can use as the procedure as hardware, and we have this sequence. You can see here the past sentence is quite changes and quite different. In this way, we have at the end, we have a reduction of driving time less than 15% in this way. Then we have what means that. And then in this way, we can use a more stable situation, is taking the information of the users. So we are able also to take into account the opportunity that in these travel time simulations, the preference of the drivers and so on. Now I skip this. We can go also the opportunity that are offered by telematics. But telematics also can improve the collaboration and cooperation. We did some experience with the colleagues in Colombia guys in Medellin. And we know that now the current situation is that we have in the just-in-time for retailers. I booked for to have 2 boxes of cheese for tomorrow morning at 9. I have a new demand. I don't want 2 boxes, I want 4 boxes. But how we can accomplish this change? We can accomplish or not? We are able, if a single operator is difficult to accomplish, because if my driver left the depot, it's very complicated to return to the depot to reload, to do the reload. But if we become a cooperation, a coordination with the users, we can share the load. We can share with the customers. We can have an app, and we can try to accomplish the request. In this way, of course, we can also have some changes in the network, congestion, so on, and then we can try to take into account the stochasticity of the demand, but also the stochasticity of the supply, in order to reduce the vehicle kilometer and to reduce the externality producer. We did this with trying to define a platform that was tested during a digital twin project. This is the general procedure that we implemented. We implemented the service of customer by customer to business and business to customers. And we try taking into account the stochasticity of the network and of the demand. We did some example. I go ahead in this presentation with taking into account. We did some digital twins, and we did for the city of the Medellin. We had these 20 customers. We did some simulation, and this is the opportunity. Then we tested through real cases what happens during this situation, and we were able to identify if we can accomplish the request from the users, or to take into account that the evolution of the network. This is some example that's when we can solve, and the results that are quite significant. At the conclusions, of course, this I tried to open some questions, some opportunities offered by the in this conclusion. This is we have a lot of opportunity for the future. I don't want to go inside each by each, because I left the slide and I asked our Stanislav and Olga to share with you, and I remind to your disposal for opening. Also, many of them are coming from the autonomous vehicle, as yesterday Stanislav showed you, with John and so on, or the opportunity to build the digital twins, as Stenia yesterday showed us, with the opportunity to use the current modeling framework for simulating the system that we can integrate, and so on. And of course, we can have a lot of opportunity sources. It is a very challenging questions that I would like not to go inside, because there is a different situation. For example, one of the points where we are working, we suggest a path, and we have used an updating of the cost. But now we can see, okay, the system is evolving in another way. Change the choice, the path, change this. This is an open question. It's likely that we got that we don't, when we suggest to change the path, to change the direction. So all this is open information that we can see in the next future, in the next future. Also, the energizer is important to reduce these impacts and so on. I will stop, and we have, because this is a very interesting questions, and I hope that many of these topics are under discussion with with the colleagues Francesco Russo, that is a pleasure that and from the Mediterranean University, that we are working about that, and we are trying to evolve this way. Thank you for attention. Sorry for this a lot of information, but my fear was is that you can have the opportunity to have a lot of an open view on how the challenges are very many, because the things that we are saying is very complicated. We have a lot of things to do for improving civil logistics, but we have to. I would like to have to provide you a larger panel that we can adapt in your bachelor degree, and is more specific for updating or completing creating new courses. Thank you for attention, and if you have questions, I am open.
Do you understand correctly? You use a typical model for freight transportation?
Yes, we use we identify usually when we use planners, navigators. We are usually they use a cost that is or monetary or distance is a proxy or travel time. We we think that it's better to use a generalized travel cost that is a combination of different attributes. Because when you driver choose a path, is a combination of travel time. It's not always time. It could be a hyperweight, but also depend on the stability of the travel time, the stochasticity of the, for example, sometimes, or you can decide to go in a road, indeed of another one, because you know that the travel time is about 10 to 11 minutes. It's a little bit higher than the other one, but it's stable. Then the other one can be completely free or not. You can delete it. We use a combination, and we use this a combination is like a generalized cost.
This is the first research where you use the model.
No, because usually we use the environment, this type of approach. In general, we use this one in our simulation, in our proposal, and so on. Usually in the weekly, because we have two different aspects. Now I concentrate on supply and the costs, but otherwise we can also concentrate how the people choose, and we have the behavioral model for the choice. Also, how we can suggest to change the paths, to go another way. This is, I think, that is what is better to use for improving, for taking into account the different behavior and the different point of view of the users that are within the system.
One short question. Slide number 36.
Oh, we
36.
36, yes, 56.
With roots. So, for example, do I correctly understand? For example, you have route suggestion route at certain time. For example, 9:30.
Okay.
Yes. You have route which defined according to the situation.
Current situation now.
Currently, yes. It is started.
Yes.
But in the middle of this route, something changes. You said.
No, I said that it started at 9:30.
Yes.
You go to, and then you go to the first customer 2.
And the situation changed. Can he?
You can launch again, and the assistant continue to say, okay, to go to 1, 2, but the other one changes. For the circumstance.
Now I understand.
Okay.
Yeah.
I have a question. How does vehicle's load capacity affect on characteristic of delivery road?
Okay, this is a very challenging question, because as I said before, now we have some constraints for accessibility, and the public administration try to solve that issue, saying, okay, we don't want EV vehicle inside and they reduce the load. But reducing the load doesn't mean that we increase the capacity, the load factor, because it's more complicated for them. And then it's a very challenging question that we have to try to solve with the cooperation coordination. If we move towards, for example, in the city of Medellin, so we have to solve using combination where the operators are working together. They share the vehicles, and it's more easy because we have a central center that can collect the requests and can optimize the load. But it's difficult if we continue to have a lot of operators, a lot of vehicles, the load factor is very low. We have to think that in Italy we have this average load factor is in the city is less than the 30%. It's very low because otherwise, and it depends also by the type of freight, because some factor is not only weight but also in volume. For example, after I transport clothes, they occupy a lot of space, and it's not possible to put more. If we use a weight, is enough. But it's in my opinion, in the solution that we have in the mission, the coordination cooperation could be, or all the measures, the action that allow to share the load could be a good solution.
Thanks for your answer.
Thank you.
Thank you much for your excellent lectures. It's highly relevant for education, research, and practice. But the issue, internal issue, remains in the context of sustainable development. How do you think? How can we balance requirements of sustainable development with economic efficiency? What is quantitative criteria for this? Criteria of balance.
Okay, balance. No, it's clear that we have, as I started at the beginning, we have 2 points. One is the transport operator that meant that we reduce the environmental. For example, remember, because sustainability that means only pollution, but means congestions, means road safety, and so on. For concentrated, for example, for pollution, that means I have to reduce the cost because at the end I have to reduce the cost. And then it's, but if we are able to reduce the operation cost, the total delivery time, of course, we can reduce the vehicle kilometers. Vehicle kilometer is better, but for point of view of transport operator, because we reduce the cost, we the working time, and also on the point of view of transport operator, because of the public administration, the sustainability of the system, because we can able to reduce the number of vehicles circulated, the kilometer traveled, and then we have reducing. We can improve the sustainability. Of course, we have to find the right balance, and we don't have the same solution, the same plan for each city, because it's specific for the different interests, the different configurations, the different characteristics of the city. We have to balance this. It's difficult, but we have to investigate different points. Then last one, and then we go to.
We have one online question also.
We can discuss by myself, and sorry, because after otherwise I have time for 2.
I think discussion is the main important part.
Okay.
The question online, you can
Okay.
now and then.
We'll start online and then
after the
after-
coffee break. The physical one.
Okay.
It's very possible.
Sorry. Bye-bye, please.
I can read, yes, because somebody, our innovations, Katerina Vakulenko asks you, our innovations and developments in the transport sector are deeply integrated with the internet. Do we have a contingency plan, in place in case of a major blackout or connectivity loss, like ones experienced in France, Spain, or?
Okay, this is a great question, but we are going to doing the residence of the system, and of course, this is a description that of the system. Of course, we can take, and we don't have now a lot of experience. We are focused on the usually working. Of course, the connectivity could be an issue, and we have, if we move a lot to connectivity, we came back. We have to take into account, but we are, and we have to investigate this. How we deal with the disruption of the system and how which is the solution. This is very interesting challenges that we have to solve. And I can understand it. Okay, please, and then we can.
Antonio, I was to ask what benefit mandatory cost or time cost reduction can be achieved by using this in the average.
In average, for example, in this average, we tried to have these data are real data that we collected within the city of Rome to monitoring for 2 months before the city and the city. This is, and of course, this is a benefit. We estimate that the benefit to use this information, of course, can be is about 20% in terms of time. It means that you have only a very quick calculation. 5 drivers. If you reduce to 20, you can reduce 1 driver, and this is a very interesting concept. Okay, this is. Okay, thanks you for it. Okay, now, so.